Hello and good day to all of you. It's my pleasure to welcome you to today's cooperation webinar of IDEA StatiCa and Dlubal. This webinar will be focused on the effective BIM Link workflows between Dlubal programs, RFEM and RSTAB, and IDEA StatiCa connection. So, my pleasure again to welcome Daniel Dlubal from the Dlubal company. Daniel, how are you today?
Hello guys from IDEA StatiCa. Yeah, I am fine and I am very happy to be part of this webinar today with you guys. I hope you will enjoy it.
Great, thank you. And from our side, there is Lukáš Juříček, product engineer. Lukáš.
Hello guys. Yeah, I feel really well and looking forward to this webinar.
Great to hear that. Okay, first, thanks, a big thanks to Dlubal and Daniel for being here with us today. Dlubal is our technology partner, and we cooperate on the improving the BIM links and the workflow, of course, and it's going pretty well. And we'll show you today how this looks like and how you can benefit using those two programs. So one last thing from me. For a beginning, we are running on platform GoToWebinar. You are all muted, but feel free to type in the questions, anything that comes to your mind, into the question panel, and we'll be answering them on the way during the webinar. We will then answer some of them at the end, and if we don't have time to answer all of them, you will get the answers later by email. So now it's time to pass the presenter to Daniel, who will continue with his presentation. So the presenter is yours, Daniel. And
okay.
You can continue. Thank you.
So, thank you for the introduction. So again, my name is Daniel Dlubal. I am responsible for our German team and support our team regarding marketing and also the customer support. Maybe for those guys who are attending this webinar, I want to lose some words about our software company. So we are structure analysis software developer. We have more than 30 years of experience in developing structure analysis and design software. And currently we have around 10,000 companies who are working with our softwares worldwide and also using the software in more than 95 countries. And also our company currently employs close to 300 team members. And we have 10 software offices all around the world in Germany, USA, Italy, and also Czech Republic. Yeah, few words to our main programs. On the left side, you see RFEM. This is our 3D finite element software. Software for all application areas. And on the right side, you see our structural analysis frame software for the calculation and design of beams, frames, and trusses called RSTAB. RFEM, it's suited for the calculation of frames, beams, plates, shells, and so on. Only with RFEM you can calculate support reactions, internal forces, stresses, and strains. The design of different application areas like steel or timber structures you perform in our add-on modules. And then we have RSTAB. This is suited for frame and beam structures, so only these kind of member structures. Yeah, and then I jump in our program RSTAB. So today we will model together 2D truss and very simple 2D truss, and then we export the connection to IDEA StatiCa. So I create a new project. I click here on new and enter here a name 2D truss. And my type of model is 2D in XZ. And I refer to our Eurocode standard regarding our load cases and combinations and choose the European National Annex. And I want to create my combinations automatically. This helps me a lot, makes the work easier. Okay, then I click OK. And RSTAB offers me a very nice tool for generating simple structures. So here in the menu bar under Tools, I go here to Generate Models, and here I have the possibility to create a 2D truss very fast. I click here on 2D truss, and here I have various types of trusses. I choose here this truss, so with a straight upper and lower chord, this type of diagonals, and the number of bays is 8. My truss has a total length of 20 meters. Total height is 1.5 meters. And I omit the verticals, so it looks like that. Here we can see it in the left bitmap. The only thing I have to do is the creation now of our cross sections. So for the upper chord, I create a new cross section. I click here on this icon, new cross section, and I choose square hollow section. And in this case, with a profile of 150 times 6.3, so the thickness. I click OK, and then again on OK. And for the lower chord, I have the same cross section, only for the diagonals. I choose a different cross section. Again, click here on new cross section, and here I choose a circular, so a rolled cross section, this one. And this has a diameter of 114 with a thickness of 4 millimeters. I click OK and submit everything. And now we can see here our truss. So again, very simple and very fast done. So the only thing I have to add are supports. So I select the left lower corner, go to new nodal support, click on OK. So I have here this fixed support, and now on the right side I want to slided support, so sliding in the X direction. I click here this one, and now my structure is done. So in order to check my model, I can display my structure in different colors according to cross sections and member types. I will do it. So I go here to the display navigator on the left side, go here to colors and graphics according to cross section, and now I see here different colors which are showing me the different cross sections. And the same I can do for the member type. And as I can see here, I have 2 different member types, the BIM member type, who are transferring all internal forces, and the truss member type, who is generally a BIM type, but at both ends it has hinges. Okay, so the next thing is the definition of our load cases and load combinations, and then we apply the loads. So for the definition of our load cases, I go here to new load case. I have 3 different load cases. The first one is the self-weight. So I insert here the name, and my action category is permanent. Important is that the self-weight is activated. I create a new load case. I can also pick up here one of our descriptions. So in this case, I choose here as next load case the snow, and the action category is selected automatically. And the next load case is the imposed load. So in this case, installation category A. I click on OK. And now I jump back to my first load case, in this case, the self-weight, and I apply the load. So for my upper chord, I want to create a new member load, in this case, distributed load, so uniform, and the load parameter is 1.5 kilonewton per meter. I select all members in the upper chord, and as you can see here, every member load is applied on one of these members. Now I jump to the next load case, the snow. I want to show you another possibility of applying loads. As you can see here, we have here a light framing around our members. This framing is called set of members. What are set of members? Sets of members must be understood as combined members. So you can use them to treat several members as one member. And this helps you to apply loads easier, to interpret results easier, and also for the design of steel structures, it's easier for the design add-on modules. So I click here on again, new member load. And now I refer to sets of member. My load parameter is in this case 3. So for the snow, I click on OK. And now I don't have to draw a selection window above all members, only this set of member. So, and the same thing we're gonna do for the installation. So I click here on new member load again. The load parameter in this case is 1 kilonewton per meter, and I choose the lower chord. Okay, good. Now let's go back to the definition of load cases and load combinations. I want to lose, there's also some words. So load cases in this register, I think this is pretty clear. Then the actions, I think this is also pretty clear. Combination expressions. There I only want to consider the ultimate limit state and the characteristic serviceability state. So the other one, frequent and quasi-permanent, I don't need, so I can delete them. Only these two. Jump to the next tab. This is the action combinations, depending on the defined combination expressions. And now I go to the load combinations. The load combination, the loads from the included load cases are combined, considering the partial factors and also the combination factors. As you can see here, maybe let's take a look at load combination 3. Yeah, here we can see, okay, snow is the leading one, so the full partial factor, and the installation is not the leading one, so it gets this extra factor. Okay, and now we have also the possibility to have a result combination. So in a result combination, you can superimpose the results of load cases, of load combinations, or also result combinations. In this case, we have here this one. So of all load combinations. So it has a big advantage when you want to see the minimum and maximum values of the results. Okay, everything done. So I click here on calculate all. And now I see the deformation as first result. Here on the left side in the results navigator, I see here different chapters, members, and super directions. So let's check them. Global deformations, yeah, seems pretty okay. I can show me the deformation a little bit better. Maybe just go here to the display navigator and go here to deformation and the chapter members and say, okay, the cross section should be colored. And then I can also deactivate here the separation lines, and I see this structure right now. Okay, yeah, I have also the possibility to check the internal forces, maybe check the normal forces because we have a truss structure. So as you can see here, the typical behavior of a truss girder is that we have here in the lower chord tension forces, in the upper chord pressure forces, pretty clear. And I have also the possibility to see the super directions. And also here, as I said before, the result combinations. So this enables me maximum and minimum values. And I can show me also both results. Okay, this was the normal calculation. Now let's go to the design of this structure. Therefore, we can use our add-on module Steel EC3. Steel EC3 is mainly used for the design for steel members according to the Eurocode. I double click on our add-on module. And here I choose all members. So I want to consider two cases. The first one is all diagonals, and the second case is the lower and upper chord. So I choose all members. I click here on select members to design. And now I can do a specific design because I know all members who are diagonals has the member type truss. So I go here, select special. I click here on members and then with type. And now I select the member with the type, in this case, this diagonal. I click OK. And as you can see, when I deselect the results, all diagonals and also this vertical member are selected because they have the member type truss. I click OK. And now I want to design it with the results of the result combination. So I select this one and I go here these chapters through cross sections. Yeah, so here I can see which cross sections are selected for the design. Intermediate lateral restraints, especially important for the buckling and stability, and also here effective lengths. So in this case, all members will be designed by the equivalent member method. So the buckling length are also the normal length. So I calculate it, and I can see here the design ratios, the results, and also when I look at the cross sections, I see here the different proofs designed according to formula and so on. So this was our first case. So I will rename it. I will call it diagonals members. And now I will create a new case. In this case, I will design the upper chord, so with that one, and also the lower chord. So these are sets of members. Good. I want to save my changes. And now I select no members, but sets of members. So very easy. We have only these two. I choose for the ultimate limit state my result combination 1, and for my serviceability limit state as well as the characteristic 1. Okay, now the tables here on the left side are the same, materials, cross sections, and so on. It's always the same. Now I want to do also a stability design. So the Eurocode 3 doesn't support the stability design of hollow sections with the general method. So here in the tab stability, I have the stability analysis method of sets of members. And for hollow sections, the Eurocode don't have any solution. So we can't use the general method. We have to use for hollow section, in this case, the equivalent member method. The general method is mainly used for these high sections, high profiles, IPE, HEA, and so on. So I click on OK. And now I go here to this table, effective lengths. And for my upper chord, I assume that every 2.5 meters, one purlin support my truss horizontally. Yeah, so I have horizontally supports. So I have to check the buckling axis. It's not 20 meters because 20 meters are the whole length. I have only 2.5 meters because I assume, okay, every 2.5 meters, one purlin will support my truss. Okay, and the same also with the other local axis. And as we already saw, the lower chord of my structure contains tension forces, so I don't have to consider the buckling or the stability design of this lower chord. And here the lateral torsionally buckling, as you can see here, is grayed out. This is because these torsional rigid cross sections like this hollow sections can be neglected when doing this lateral torsionally buckling. So now, last but not least, the serviceability. So I refer to sets of members. I select both of them, and the reference length is 20 meters, and everything was done. So I calculated again, design it, and I see, okay, everything works. I have a good design ratio. Perfect. So this was the modeling, load application, and design of this simple steel truss to this truss. And now we can export here this node, and this will be the task of Lucas. So I will forward to Lucas.
Thank you, Daniel, for impressive presentation and modeling of the 2D truss with the code checking according to Eurocode. So I will take a presenter, and I hope you will see my screen and application IDEA StatiCa. So now it's time for running the BIM Link, but at first we have to install the BIM Link. So at first I run IDEA StatiCa application, go to the chapter BIM, and here's the only one option: activate your BIM Link. If I run it, you can see there is so many softwares, and both of them are RFEM and RSTAB, and the softwares have been already installed. So the BIM Link is ready for using. So this is the first step, and now I can come back to RFEM model. I have completely the same model as the Daniel, and all load cases, self-weight snow installation, also the combinations for ultimate limit state, and result classes for ultimate limit state also. So at first I have all results. Now I have to calculate it, so calculate all. This is the linear calculation. So we obtain the internal forces, bending moment, normal forces. And I would like to export the node of the upper chord with these two diagonals. So I select it and go to the add modules, and this is the external module. You can select CCM or checkbot. This is for the latest version. We are using IDEA StatiCa checkbot. For older versions, we are using IDEA StatiCa CCM. And so I will select IDEA StatiCa checkbot. Yeah, and the application is starting. Yeah, now we are here. So you can see we are using Eurocode, but there is also the option to select, let's say, AIC or Canadian code, Russian, China code. And so, but we will use Eurocode standard. After that, we can go to the settings, and we can also change the units. Normally for Eurocode is a metric units, but there is option to select imperial if you would like to do the code check in the AIC. So come back to the new. This is my name, IDEA StatiCa Trust Beam, and project the path where the project will be stored. So continue. We are inside the application IDEA StatiCa checkbot, and there are two options. We will use connections because we would like to do the code check, design and code check of the connection. So I will press the button and the selected joint will be imported to checkbot. You can see this is the node number 7. The numbering is the same as in RFEM or RSTAB. And this is a wireframe model of the joint with the massless node. You can see if I click on every member, the members are getting, say, orange, and I can see that this is selected. I have also the option, or the software give me the option to merge the member. The option is available or suitable if you want only one member, but for our situation it's not usable. So at first we will define the loads. If I click on the definition of the loads, in the left side, or on the left side of the window, will pop up the self-weight, the load cases like a self-weight, snow, and installation. It's completely the same load cases as in the RFEM, and the group LG5, and there are 5 combinations for ultimate limit state, because we will use for design of the connection the combination for ultimate limit state. The serviceability limit state combinations will be neglected. So we can move to the next. The combinations have been predefined in the RFEM. So we have to use not evaluation according to code 6.10, but the envelope, because we would like to find out or select the most critical combinations from these 5 combinations. Yeah, for ultimate limit state, we are in the tab of the result classes, and we will work with the ultimate limit state combinations. So for our case is important CO1. It means this is the result class combinations for ultimate limit state. So I will finish it, confirm it here. Yeah, and now I can open it. The IDEA StatiCa application is starting, and in a few seconds we will see the shell model of the joint. with all internal forces or all combinations. You can see the program automatically detected 4 critical combinations for this joint. In the RFEM was detected 5 or was created 5 combinations, but our internal combinator automatically detected 4 critical combinations for this joint, truss joint. You can see the members are numbered according to the RFEM, and we will start with the defining of the topology of the model or model type. This is a 2D truss, so we have to put some constraints for the upper chord 4 and 5 member. We will change the model type for the plane model, where only normal force and the shear force in the Z direction and bending moment in the Y direction will be considered. It's same as for member number 5. And members 20 and 21, these are members which are truss members, are considered as a truss members. So only normal force and the shear force can be transferred through these members. So we have to put it there. For member 20, we use model type where will be considered only normal force and the shear force. And for this diagonal 21, we use it in the same way. So the model, from the point of view of the model type, is ready. Here are the combinations and graphical illustration of the normal forces, shear forces, and the bending moments. You can see there were transferred only normal force, shear force, and the bending moment in the one Y direction, and all the other forces are neglected and are 0 from the RFEM. What is very important to have the unbalanced forces 0. It means that the connection is in the equilibrium. So if now it's time to create or design this joint, we can use 2 approaches. At first, if I click on this member with the right mouse button, I can connect to the other member, and some predefined templates will appear and I can select. So I select plate-to-plate connection with the bolt M16 grade 8.8. Now the plate or the joint was automatically designed, and I can edit some parameters in the right part of the window. So there will be connected member 4 with the member 5. The thickness of both plates will be considered 12 millimeters or 12 millimeters. The connection type will be bolted like this, or it can be welded. And the dimensions of each plate will be to profile aligned, not to profile symmetrical, because it will be the dimensions will be different. The top part is it's measured from the section, top, left, bottom, and right. This is the top. This is the bottom. This is the left, and this is the right part. So I will put some dimensions. This is 180 millimeters. This is the dimension. You can see it here. The left part is 20 millimeters. The top part is 80, and 20 millimeters the right part. So now we have prepared the plate with the correct dimensions, and we can continue to the board definitions, to board grid. So the top layers will have distance 45 millimeters from this edge, the upper edge, 45 and 90. You can see these are the dimensions, 45 millimeters and next 90 millimeters from the first created vault. Left layer is minus 20 millimeters. It's aligned on the left side from this edge. The bottom 40 millimeters, and also the right layer in the same, to have it symmetrical, minus 20 millimeters. So you can see it looks like this. And what we have to do now, some weld definition. So for flanges, it will be without welds, and for webs, we will use 5 millimeters weld definition, or 5 millimeters throat thickness. Okay, so we bonded these two members, and now it's time to create the operation for member 20 and member 21. With the right button, you can see it's not working, no suitable template. So we have to go through the operations with the right click button and new operation create. We will use gusset truss member. It's mainly used for truss members, and it will be connected. The gusset plate will be connected or will be created for member 20. And it will be connected to a new plate, and the new plate will be related to member 4. You can see it's getting automatically elongated. The member 4 was automatically elongated to some predefined length, and it will be also related to this plate. It's a plate PP1A, so I will use it, and it's fixed. It's welded, and we can continue to the definition of the dimensions, the plate. So the thickness will 10 millimeters, the width 360 millimeters, and the depth 150 millimeters. We can let it. For connection, we use the rectangle notch operation. It means you can see it's automatically cut it off. I will turn off the load effects, and now you can see the plate is cut it off and it's welded. Okay, I will come back to operation gusset plate, and I can put some notch 10 millimeters. And all the welds has 4 millimeters throat thickness, and will be both or double fillet weld. Okay, now it's time to copy this operation and change the member. It will be member 21. It will be related to member 5 and the plate PP1B. This plate. Now the joint has been created, and we can run the calculation. So I turn on all predefined or all exported load effects and run the calculation, and we will see what will happen, if it's sufficient to have all these welds, bolts, or if we have to change something. It's nonlinear calculation because we consider ideoplastic diagram of the material with the maximally 5% of the plastic redistribution or plastic strain. It's according to code. So the plates can be on the plastic branches. Also, the bolts, the code check of the bolts is according to code, where the bolts are considered in the tension and in the shear also. And the welds will be code checked for equivalent stress. So all normal stresses, shear stresses in the parallel and the perpendicular direction are considered in the equation for code checking of the welds. You can see we have 4 combinations, and we are done. And we will see the results. On the left side, you can see the analysis. There were 100% of the loads was considered. The plates were on the 0.1% on the plastic branch in some places. The bolts, the maximum utilization 0.6%, and the welds utilization 75%. Also, we consider for rectangular core section or hollow core section, which are circular or rectangular, we consider geometrical and material nonlinear analysis due to, let's say, big deformations. So we can go to the check and see the results. You can see all cases are in equilibrium, and we can display equivalent stress on all plates. Yeah, I can see the tab with the stresses on the plates with the maximum spots. I can also display the mesh. It's very important for interpretation of the results to have a correct mesh. So you can see that the maximal place with the maximal stress or distribution is in this place. It's very well visible from the deformation. I can scale it a little bit. It's only for 10%. I can let it 50% of the deformation. And we will see what is happening on the joint. So you can see here is bending moment. So the deformation is correct, and the peak of the concentration of the stresses or the distribution of the stresses is here. We can see also the plastic strain. The plastic strain is only at this place. Yeah, it's only small places. Yep. I can move to the bolts and show the bolts forces. The bolts forces are really small because big normal force, which is compression force, let's say, is fixing this or is keeping the stress or the forces in the bolts. So the force is really small. This is due to the stress in the contact, the big stress concentration. You can see if I click on the plate, I can see the stress in contact. Okay, if I will go to the bolts, here is the plus button, and all the code check according to code can be printed out and are visible in this equation. Tension resistance check, punching resistance check, shear resistance check. Here is the equation. Value is higher than the design value. Yeah, all is perfectly described. And we can move to the welds, see the equivalent stress on the plates. It's also relevant for welds. And you can see the welds is discretized with the maximal place. Here, if I click on it, it's visible in the tab. I can open it or scroll it down through the plus button, and here is the code check for equivalent stress in the welds. I can also, with the right click button, to print preview, and we can jump to the report. The report can be printed out to the Word document or the PDF, and it's also customizable. You can set your own report. Yeah, so project data, how it looks, the model design, cross sections, combinations, general or summary overview of all code checks, and yeah, the utilization in the stress, strain, bolts definition, bolts code check, weld code check for every part of the connection, and explanation like a code settings. So this is the IDEA StatiCa connection, but let's imagine that you would like to send IDEA StatiCa file to people which don't have it. So you can also do it, and he or she can open it through the viewer. So I save it, go to our web page, ideastatica.com, and if you scroll it down, here is a viewer. So I will open it, and I can upload the model which has been created. You can see it's a project with the node number 7. Yeah, and yeah, it's sorry, it's a wrong project. It's here, connection. So yeah, so this is my connection. Save it, and I can export it to the 3D DVG file. Yeah, so I can download that. It'll take a few seconds, and after that I can open it in the AutoCAD to see the 3D rendering or 3D view of the created connection. So it takes a few seconds, and yeah, you can see this is our connection, and yeah, it looks like this. So that's all from my side. I will pass the word to Adam. Adam, are you here?
Yes.
Perfect.
Let me take the presenter.
Mm-hmm.
And so we're getting close to the end of this webinar. Now, about questions and answers. We've been answering your questions during the webinar in the chat, and I have picked 2 most interesting questions that could enrich all the other attendees. So I will ask Lukáš about it. There is a question, I will just read it loudly. So from Frederick. I installed the latest version of RFEM and I want to use the BIM link to IDEA StatiCa, but I cannot install it. The BIM installation window in IDEA shows that the BIM link is already installed. Can I do something? What can he?
Yeah,
help?
It's a really good question, Frederick. I will take a presenter. So you have say some advanced option how to launch the BIM link. So if you will go through the program files, you find IDEA StatiCa, you find the version, related version, and you will sort it according to the type and find the BAT file. The BAT file for RFEM. Yeah, it's RFEM. It's a DLL. I have to find the BAT file. Can't find it right now. It should be. Where is it? Where is it? Wait a minute, and here should be BAT file. Right now I can't find it. I can't find it. It's a DLL. So right now I can find it. I'm sorry.
It's called
Here. Sorry.
Or...
I have it. It's in the bottom part. IDEA to RFEM. Yeah, here you have IDEA for RFEM, and if you put or hit the right click, run as administrator, so the BIM link will be installed. Yeah, it's same for RFEM and also for RSTAB. It's same RFEM, and here's a RSTAB. Yep.
Okay.
This is the answer. Okay.
This is the kind of a manual installation of the BIM link. So if you run this BET file, it adds the BIM link to all of your RFEM or RSTAB installations, right? Good. So this is the way how to help in this case. And then there is another question about importing loads. So questions from Johannes. I have 32 combinations in RFEM, but in IDEA there are only 18 combinations. Is this error? So Johannes tried the import, right? And he would like to have the 32 combinations in IDEA.
Yeah. So
what happened?
I think I can answer. I will use the same model as in the presentation. If you go through the definition of the loads and to the result classes, you can see that we have used result class combinations. It means if you are using a result class combinations, you use also our internal combinator or some selection algorithm for the most critical combination. If you want to put all the combinations from the RFEM or RSTAB, you have to put it away and use all these 5 combinations, no result classes, but the load combinations. If you put it here and go with the finish button, so all 5 combinations from the RFEM, this CO1 to CO5 for result classes will be included in IDEA StatiCa connection. There are 2 approaches, and it's up to you. You can see all 5 combinations are considered. Okay.
Good. Okay. So if you leave the default settings, the unnecessary or not dangerous combinations will be filtered out, right? But
right.
You have this option that you have showed us that you can import really all the combinations if you like, or select just some, maybe.
Yep.
Okay. Good. I think we can conclude this webinar now. I'll take the presenter back and continue with the presentation. Thank you, Lukáš, for answering questions and for the demo. Thank you, Daniel, for the presentation and demo in how to effectively model and co-check the steel truss. Lukáš showed us how to effectively import connections to IDEA and co-check and design the connections. So following this workflow, we can, it's probably the best performance how to design, co-check completely a steel truss itself and its connections. So if you imagine we spent, I don't know, half an hour of work time, and we could do a few more connections and the job will be done. Just print out the report. So that's quite impressive. So thank you both, guys. And I have one more slide here to remind you that after webinar, I ask you kindly to fill a short survey. We'll be able to find a recording of this webinar if you would like to play it again or show it to somebody else. It will be in our support center and YouTube channel of IDEA StatiCa. Of course, for free as well is the trial version that you can get on our webpage that lasts for 2 weeks and has all functionality that we have and we can provide. Next to that, in the support center on our webpage, you can find a lot of more information about the program, more webinars, blogs, and so on. So all the content. Okay, so that's it. Thank you very much for attending this webinar. I'm looking forward to meeting you on some other of our sessions, hopefully another cooperation webinar as well between Dlubal and IDEA StatiCa. And enjoy your day and see you next time. Bye-bye.
Bye.
Thank you very much. Bye-bye.